Hello, dear students. Again, now I'm going to talk about 5.3, which is plane or manipulating with the graph of sine and cosine especially. In this section, you are learning to how to sketch, for example, if you have y is equal to 2 minus 3 cosine x minus 2 pi, and also you have a 5 here, for example 4. So how we scale this graph together? Now how many steps we have? 1, 2, 3, 4 and 6. Now I combined, or I mixed a complex example for you to sketch it, but before you try to do it, listen till the final minutes of this, the last minutes of this video, because step by step I'm going to discuss, or I'm going to teach you how to sketch this graph. First of all, we have, of course, if I have y is equal to sine of x, you know the graph is easy and is like that. If I am going to the positive part, we start with the 0 and go on, and this one are repeated again, oscillated. Also this oscillation is repeated again, so I am just focusing on this from 0, pi, 2 pi, and of course here is pi over 2, right? And this is 3 pi over 2. So this is the original function. Now I am going to manipulate with our example. As I told you, I need finally to do something like that. Sine, for example, 4x minus pi, like that. So how can how to change this one, how to transform, how to advance this example to that one? So I'm going to give you one by one. And really, in this example, in this video, I'm not following your lecture 1000%, because I will leave these examples for you, and I am going to give you new more examples. So it means that this is will be like a more practice for you, more homework for you. Just do it by yourself, okay, dear? So in this example, or in the same shape of the example one, if I say like example one in your lecture note, I say like in page 141. So if I say y is equal to 2 plus or sine of x, so how we sketch this example, you know, this is the original one. Now I am, because I have addition outside the function, so means that I'm going to up. So if I'm starting from 0, 0, and you know the range of the sign is between -1 and 1, as you know before. So now I am going change this period between -1 and 1 to another thing. So if I say plus 2, so it means that 0 plus 2, I get what? Plus 2. We have like that, 0, 1, -1. So I say 0 plus 2, so is equal to 2, as you know. So my graph will start with the 1 and going to like that and like that. So how about here? Before, in the original function, my range was between -1 and 1. So -1 plus 2, I will get 1, and this is 2, and this should be what? 3. You know why? Because 1 plus 2 is equal to 3, 0 plus 2 is equal to 2, -1 plus 2 is equal to 1. That's why my graph will be something like that, okay, dear? So if I say 2 plus, means that if here's 1, -1, 2, 3, my graph will change it to like that, and will be between 1 and 3, okay? So here's my graph. I think it's easy, just like a copy and paste, but we just shift it to up. Okay, shift it to up. If I say if I say -2, we're going to down. So that's why I have 2 plus sine x is just what is my original function, shifting to, or vertical shifting, or shifting to forward, upward by 2 units. That's why 0 2 1 3 -1 to 1. Okay, dear, that's the first number, or first step for manipulating or changing the original function. Now I am going to give you example 2. As I say, y is equal to minus sign. Now if I have minus sign, how I deal with this one, and later in the example 3 I will change the 2 with the minus. Okay, so in the example 2, in my example, so how we change this one, this is my, for example, my original one, as you know, 1 and -1, this is the 0. So for minus means that minus outside the function means that x-axis is our mirror. So this part will change to like that, and this part will change to like that, and go on like that. Okay, how about the other part? If you want to do it as a copy paste, as I told you. There is nothing important, but you should focus on the sketching the graph. Now in the example 3, I am mixing 2 minus sign of x. Look, I mix it, example 1 and example 2. So it's really easy for you. First of all, try to forget about 2, forget about minus. Say I have what? I have sine. Okay, dear, 1 and -1. Okay, now I have plus 2, means I go to up. So here's 3 and 2. So here's my graph. Okay, now because I have a negative means that opposite this part, and go on. That's all. So your function or our answer will be like that. Okay, between 1 and 3, and here's 2, and my graph will be like that. Okay, dear, this is just for verifying, or just for clarifying your answer. That's all. I mixed example 1 with the 2, example 2, and I got a new function. Now how about amplitude? Now I'm going to this number 3. 1 2 3, as I told, this is example 1, example 2, example 3, mix it both of them. And how about this example? How about this idea 3? Now just if I have y is equal to 3 sine of x. Now this is this number when multiplied by sine, we recall as amplitude. Okay, amplitude, as mentioned in your amplitude, sorry, as mentioned in your lecture note, page 142, with the example 2 here. I will leave these examples all for you because they are the same. I'll give you extra example. That's why I leave this one for you. Okay, so amplitude means that multiplication. And sometimes you say amplitude is A. When I say A, because I have the formula for the question, I say y is equal to, for example, C, or let me D plus A sine or cosine K, okay, x minus h. Okay, that's why we recall, we can A, this one be C, that one be B. Okay, so now B plus A sine K C minus X, X minus C. So what do you mean by this one? This one is the shifting to up and down, and this is, you know, the changing the direction or the face of the function to reverse with the x-axis, and this one is A amplitude. Okay, now I'm going to do it for you. So the example number 4, our focus is what? On the amplitude. So when I have a original function like that between 1 and -1, I'm just sketching this part. Okay, when you multiply it by 3, just change this one to 3 and minus 3. That's all. So amplitude means that the range, okay, the range. How about this number 2? No, this one was the shift because outside of the sign, but now I multiplied by the sign, so it means that amplitude, okay, dear? So now in the example 5, I will mix all of them, like here, like this example. I'll mix all of them, okay? So if I have example number 5, we will mix all of them. If I have y is equal to, for example, 2 plus 3, okay, 3 sine of x. So I say this is my graph, original. Every time I'm sketching the original because really I don't know. If I don't know the original, how can I manipulate? Because we have a 3 and because we have a 2, I'm going to change it to the second one, okay? So because you have a 2, as I told you, we are going between 1 and 3, and here's 2, so this is for 2. Now again I have a graph like that, okay? Here's 3. Now I'm multiplying by 3, so it means that 3 by 3 is equal to 9, 1 by 3 is equal to 3, so it means that my graph is between 3 and 9, okay? How about just sketching an example 6? Just if we have y is equal to minus 3 sine of x. Now I mix it, example 2 with example 4, so I get what? Here's my sign, okay, dear, between 1 and minus 1 again. Now because I have 3, I will change it to between, I say it's between 3 and minus 3. I will widen the range, okay? You can just widen the range. I'm not changing here. If you want to do it on the same, okay, here's your original, okay, 1 and minus 1. So y is equal to sine x. For the next color, we have 3 sine x, so means that I have 3 and minus 3. So I'm starting with a 0 and going to up and coming to down to minus 3 again, go to up, down, like that, okay? This is 3 and minus 3. How about if I see y is equal to minus 3 sine x? So it means that the opposite of the of the black one. So here's my graph. It's going to that, I'm going to that. That's all. So our graph will be changed to what? If I am going to do it here, we'll change it to here and there. That's all, okay, dear? So I think it's easy. Now we are going to another idea in our first example that I told you. Our objective for today is what? Sketching y is equal to 2 minus 3 sine 4 x minus pi. So you got this one and minus and 3 amplitude. Now it's time for k. K is recalled as what? As a period. And in your lecture note, mention it. Here's amplitude. Go to the page 143. Here's your period. Can you imagine? Here's kx, okay? Period is 2 pi over k. Now I'm going to talk about period. The period, for example, I'm simplifying my example for getting it. So for getting the idea, so I say y is equal to sine of, for example, 2x, okay, 2x. So this number k, we say k, here's k in front of the brackets and multiplication by x. So this one, so this k is a period. How we say is period is equal to what? To 2 pi, as mentioned in your lecture note, over k. Okay, so for finding the period before, and our period, it was what? For sine and cosine. So maybe you are asking before finding the period, you see what's the period? Yes, your question should be your question. Okay, period is what? Is the time, or is the length for sketching one round of sine or cosine. What do you mean by that? So if I'm sketching sine, one good period, one shape, I will get this one. So I'm starting from 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, maybe you are going to finish the period, but the oscillate, but this one is the copy of here. This one's copy over there. And again, so you can get the one period or the one oscillate of sine, and we recall it as a period. So the period of sine is what is 0 to 2 pi. So is from here to there. So 2 pi minus 0 is equal to 2 pi. So period of what? Of sine is equal to 2 pi. Why? Because the graph of sine can be sketched by just this length, which is 2 pi. How about cosine? Let me do it for let me show you the cosine. The cosine will start from here and going to there, and look, and again. Why I say again? Because this is the copy of here, and this there, and go on. So this is my period of what? Period of cosine of x. So the period is equal to what? I don't know. From 0, pi over 2, pi, 3 pi over 2, 2 pi. So also the period of cosine is equal to what? To 2 pi, without any change, without any multiplication. So if I say what's the period of 2 sine, will change. Why? Because the period of sine, here it is, sine of x. So where's k? Can you see k? Yes, I can see k. K is equal to 1. That's why we don't write. You know, when multiply something in math, we don't write it. We don't mention, because y is an identity multiplication. So that's why I say the period is equal to k over 2 pi over k. So it's equal to 2 pi over 1, which is equal to 2 pi. That's why I said that the period is equal to 2 pi. Okay. Now how about our example? It was example number 7, I think. Yeah. Example number 7. If I say sketch sine 2 or 2 outside, so okay, or 2 inside, sine 2x. So now it's time to find the period. So I say period is equal to 2 pi over k. So 2 pi and k is equal to what? Here in this example, k is equal to 2. So I say over 2. And I will get what? Pi. Our result is pi. So means that this graph till here is pi. You know, this is the graph of sine 2x. Why I say this till here is pi? Because our period is what is pi in this example. So 0 pi. How about here? Pi over 2. How about here? Pi over 4. How about here? 3 pi over 4. How do you know these numbers? How I found these numbers quickly? Because I know, okay, this is the pi and this is 0. So pi, if I want to find the midpoint, how can we find midpoint? For example, you have a, b. So I say find c. So c is equal to what? B plus b minus a over 2. So if for example, if I say find the midpoint between 5 and 8, you see what? You say 8 minus 5 over a good number, 9. 9 minus 5 is over 2. It's equal to 4 over 2 is equal to 2. Okay, so it means that here's is equal to what? Or you can add is better. So I get what? 40 over 2 is equal to 7. Here is equal to 7. So change it into addition to get exactly the number without adding or subtracting. So if I want to find midpoint between pi and 0, I say what? I will add them and will divide them. So pi over 2, I got pi over 2. How about this one? Between pi over 2, midpoint here, pi over 2, I say plus 0 over 2. So it means that pi over 4. the same thing. Fourier is equal to 3 pi over 4. That's all. So in general, I know you are a little bit confused. In general, if you want to find, for example, y is equal to 2 sine, for example, 3 or it could be 4x, how we find this one? Before I say this is my original function. Now in the example 8 I mixed two things for you. So here is what? 2 and minus 2. Why? Because it's multi-amplitude, so it's a. Okay, now how about the period? How about the one period of this part till here? So 2 and minus 2. How about the period? The period is k is equal to 4. So period is equal to 2 pi over 4, which is equal to what? 2 pi over 2. So here it is. Here will be what? Here will be yeah, 2 pi over k. K was 4. So here it will equal to pi over 2. So I see here is equal to pi over 2. Oh, sorry, pi over 2. Okay, dear. How about here? Divide is equal to pi over 4 and go find the other part. That's all about what? About finding periods of the function. Okay, dear? Good. So now I'm going to solve another example, example 9, but with a rational amplitude, rational, what do you say? Rational periodic. What do you mean by this one? For example, I have 2, or let's just simple function, sine 1 over 2 x. So how we solve this example? Then you can find the more details in your page 143 in example, I think example, let me find for you. Example 3, you can find more details. Okay, you can combine with them. The example 3 in page 144 in your lecture note. Okay, so about a rational period or rational k. So I say k, a is equal to 1, nothing, so I just 1, and k is equal to 1 over 2. Now period is equal to 2 pi over k, which is equal to 2 pi, k is equal to 1 over 2. Now, and you know this one is going to up 1 over 2, 2 pi, sorry, 2 over 1 multiply 2 pi is equal to 4 pi. So I got period p is equal to 4 pi. So how we scale this example? We have this original one, 2 pi. For the period, for this one, I have what? I have something like that, to 4 pi. Or you can just directly do it like that and say here is equal to 4 pi. And how about here? 2 pi. How about here? Pi. How about here? 3 pi. Okay, dear. That's all that you need about that. Another idea is what is the periodic of the function. Okay. Now, and you can, as I told you, you can find more example about periodic and amplitude. You can find, or you can sketch the example number 3. Now I am going to, in the next, I'm going to show you how to we have a phase shift in the sine of and cosine, and how we find the phase shift, and how we find the complete period between this one. And you can just see this formula. So I'm changed for you to the general formula, c plus or minus, okay, a, for example, sine k x minus b. Okay, this one is what is up and down shift. This is amplitude, this is periodic, and this is what? This is the phase shift, means that right and left, right and left and right. Okay, and how about this one? Do not forget about this one. We have addition on negative, so it means that reflecting with x-axis, you know, means that here or like that. Okay, for finding for more details about the shifting phase, I'm going to solve example number 9. I think that was number 9. Yeah, number 9 or number 10. Like example number 4 in your lecture note, page 145. Okay, so it's like this one. It's not exactly, it's like this one. So it means that I will, this is an extra example for you. Now I have what? Y is equal to sine, because I don't want to really mix with this one for you, and I don't want to use the shifting, the kb1, so x minus pi over 2. Okay, so how to sketch this one? Because as I told you, y is equal to c plus or minus sine for a amplitude, sine of k periodic, x minus b. So b is our what? Right or left shifting, so we record as a phase shifting. So for this example, if I say pi over 2, means that I'm sketching my graph. As you know, it's a simple graph without amplitude, without anything shifting to up, down, no. Negative, positive, no. Periodic is 2 pi, because here's here 1. So just I have what? I have this extra, so pi minus 2 means that here it is. So I have pi over 2, 3 pi over 2, and 2 pi, as you know. Now when I say shift or minus, as you know in the function before, we say that minus for the right side, plus for the left side of y axis. So it means that to here. Okay, so means here I have what? And I want to really mention some important things in 44, the page 144. You have what? You have this period b. I'm going to write down for b, and what? And b over b plus periodic p. And you know p is equal to what? P is equal to 2 pi over k, as you know, right? So how we find this period, how we find this range? What do you mean by this interval? So for the simple example or original function, we have this one and that one. We start with the 0 and we finish with the 2 pi, right? Because there is no shifting. But when we shifted, when we use the phase shift, so it means that our function will change to another thing. We'll shift it to here. So we start, instead of 0, we'll start with the other thing. So should we start with a b? So where is your b in your example 9? So y is equal to x minus sine x minus pi over 2. So where is b? K is equal to what? 1. A is equal to what? 1. A is here. A is here, amplitude. K is here, is equal to 1. Where's b? Where is here? Do not forget about b is minus, b is minus. So it means that when it's, we should have minus then the b. If it's plus, means that we have minus minus. So b is equal to what? Is equal to pi over 2. So means that my stage or my function should be start with pi over 2 b, and b plus p. Where's p? P is equal to 2 pi over k. Here's p is equal to 2 pi over 1. It's equal to 2 pi. So means that you should have something like that, and find the denominator if you want to exactly get nice image. Okay, nice function and graph. So I say my function should start, even you don't know how to finish this one, this is very important for you. Instead of 0, I should start with what? With instead of 0 and pi over 2, sorry, instead of 0 I should start with a pi over 2. Okay, before, so this should be pi over 2, and this one will be our 5 pi over 2. That's all. And for this, the middle point, and you know how to do it. So I'm going to sketch or to find another example. Okay, and I'm going to show you this example. In this example, you have 3. You know it's 3. Here's 3, and here's minus 3 is my amplitude. So that's why you have 3. Okay. How about periodic P? P is equal to what? P is equal to K over 2. So 2 pi over 2 is equal to 2 pi. So it means that from the beginning to the end is equal to pi. So A is equal to 3. And we should start here before this example. We have what? We have pi. Here's 3 and here's minus 3. This is pi because period is pi. Now how about changing, shifting, phase shifting? So because I have minus pi over 4, so means that B is equal to what? To write to pi over 4. So means if this is a pi over 2, this is sorry, here's pi over 2, this is a pi over 4, this is a 3 pi over 4. So it means that my function should change to something like that. Can you see? I shifted. Can you imagine? I shifted by what? By pi minus 4 to the right. So pi over 4, pi over 4. And how about the other part? I don't know. This is equal to what? I told you is equal to B plus P. Now means that pi over 4 again plus P is equal to pi. Okay, dear. So it's equal to pi over 4 this part, and the denominator, find pi over 4 plus pi. We need 4, so 4, and it's equal to what? To 5 pi over 4. So it means at this point it should be 5 pi over 4. And you can see it's your example here is very nice, and solve it. Everything is clear. You have a shift phase. So please try to solve the example 4 again by your hand instead of just looking at it here. So now I'm going to another part. I'm going to another example, I think, which another, I have an idea, a little bit more idea. Just we have what? Here's we have two ideas. Here's 2x and this is a plus. Now 3 over 4 and minus 3 over 4. And do not forget about the cosine. I left all cosine for you. And how about 3 over 4? So amplitude. Okay. How about cosine? How we solve this one? 2x plus 2 pi over 3. Do not forget about the standard form. The standard form was like that. Y is equal to c plus or minus. For example, we say a sine k x minus b. So where's x? Now I have 2x. So this one should be just x. So to get in the x, I should say a cosine. Let 2 be a common. So x, if I put the 2 here, I get what? I get plus pi over 3. That's the first idea. The first idea here in the bracket, x should be alone, single x. Okay, and the second we have addition here. Addition here means what? Means that I have minus pi over 3. So b is equal to what? B is equal to, look, minus, it's not equal to pi over 3, it's equal to minus. Why? Because you have addition here. So it means that minus. That's why you have a 2 idea, combine it together for finding the example. Now for your more exam, try to, or for your homework, and maybe I will upload for you, try to solve these functions. For example, 3 minus 4 sine, okay, x 2 x plus pi over 2, and 3 minus 4 cosine 2x plus pi over 2. And I will give you later more example in the assignment. So from now, after this video, try to solve this one, because this will be one, or the both of them will be your assignments question. So please try to follow this example. Thank you for watching this video. Have a nice time for the next session.